The mission of the Nature Conservancy is to conserve the lands and waters on which all life depends. And since 1951, we've been conserving nature, biodiversity, and ecosystem services of places as beautiful as this, protecting nature for people today and in future generations. And we've not been alone. Many organizations, from private to city to county to state and federal agencies, have been working hard to conserve the coastal lands of California and conserve them in perpetuity. And as you can see from this figure here, we've done a pretty good job of it. So our managed or conserved natural lands in dark green is about the same area as our developed coastline in California in this thin coastal band. However, our coastline is changing, and we need to start thinking creatively about how to adapt to that changing coastline. We need to allow these habitats to move or transgress in the face of sea level rise. And we need to think of creative adaptive strategies for how we deal with our human infrastructure as well. In this work, we consider all the coastal habitats throughout biodiverse California, including tide pools, seagrass beds, estuaries, wetlands, mudflats, dunes, beaches, and more. But I'm going to use wetlands as an example. We've lost over 90% of California's wetlands. And wetlands are incredibly important. They provide, as just been demonstrated, incredible importance to both humans and nature. They clean our water. They sequester carbon. They have intrinsic value, aesthetic value, incredible recreation value to our citizens and our tourism industry. And they also support thousands of species, the estuaries and the wetlands that surround them. Are important to migratory birds and their stopover as they fly from southern South America to the Arctic. They're important feeding grounds and resting grounds on that incredible journey. The estuaries and wetlands that surround them have been proven to be very important to many fishes, whether they're in the brink of extinction or commercially important species such as Dungeness crab, salmon, or halibut. And because of these services to both people and nature, the Nature Conservancy has been acquiring land surrounding Elkhorn Slough in the middle of Monterey Bay, and those are highlighted here in green, and protecting them in perpetuity. And the darker colors, the reds, are the wetlands, mudflats, and estuarine areas within those protected areas, and the lighter orange are wetlands and mudflats outside of that protected area. And now I'm going to show you a model prediction of how these areas interact with sea level rise by 2100. And I want you to train your eye in two places, if you can do it. One, in the center of this figure, on the dark protected wetlands of Elkhorn Slough, and two, in the white areas up coast and down coast from Elkhorn Slough, undeveloped uplands. And as you can see, model predictions from just tidal inundation, the critical mudflats and wetlands of Elkhorn Slough transition to deep tidal waters. This productive estuary becomes a deep bay. However, another take-home is that other areas, these undeveloped uplands, to up coast and down coast of Elkhorn Slough, could potentially become mudflats and wetlands if we allow them to. A second message here is that these possible areas of the future are where our productive agriculture is today. And this is another land use that is also incredibly important to us in California. So today we have approximately 10% of historic wetlands remain in the state. And in that same coastal band that I showed you in the beginning, that's approximately 170,000 acres. If we do nothing more than protect where these wetlands are today, we will lose wetlands. And by 2100, we'll end up with approximately 100,000 acres. If we protect where they are now and protect where they could be in the future and allow them to migrate into these areas, we could gain back approximately 50,000 acres. If we protect where they are now, protect where they potentially could be, and start incorporating natural infrastructure into our planning and our development, we could gain even more acres back. And if we add those up, which some of you, I'm sure Patrick has already done, you come up with the same number that we have now, thereby achieving our statewide goal of achieving no net loss of our wetland habitats in California. Now, there are many model predictions, as Patrick pointed out, about how sea level rise will interact with our coast, and importantly, our human infrastructure. This is a photograph I took of a high tide interacting with a high swell event and Pacifica, just to demonstrate that these coastal forces are interacting with human infrastructure now. And it's how we act in response to these ocean forces that will make incredible, important actions in the results of both nature and people. We could armor it like this, and I hope Gary's right that the age of armoring is over. And this armoring provides short-term protection from the property behind it, from encroachment. But it also disrupts the natural processes that these natural habitats provide, as was just pointed out. It accelerates erosion, and it reduces this habitat here and elsewhere. And in short, this habitat slowly is lost because it is not allowed to migrate inland anymore because of this hard structure, and it is slowly lost due to sea level rise. There is an alternative. We could call it natural infrastructure. And the basic idea behind natural infrastructure is space. The more space, the better. Vegetated space is better than unvegetated space. And natural infrastructure like this dune pictured here is dynamic. It's responsive. It interacts with sea level rise and wave action. As waves erode the base of this dune here, that provides important sand to maintain that beach and other beaches throughout the coast. Dunes can move inland if we allow them to. And the vegetation on these dunes can collect sand from the wind, and this can thereby increase in their area as well as their elevation through time, improving their services to both people and nature. These same processes occur in wetlands as well. The roots of these wetlands plants dig deep down into the earth. And just think about what power that gives them to hold on to the earth against storm damage. And those same deep roots are what make them one of the best habitats at carbon sequestration on a per acre basis. So it's how we interact with these forces moving into the future. We have choices, as was just described. We can build seawalls, we could armor. And in fact, there's an Army Corps of Engineer manual on how to do that. We know how to do that, and it's been done for years. What we don't have a manual for is using natural shorelines to protect and provide natural infrastructure. And of course, that's why we're all here. We're trying to think about that. And what does that mean to incorporate natural infrastructure into our planning and our development? It could mean not developing in an area in risk of sea level rise or flooding. It could mean restoring those critical wetlands that are so important in providing so many important services. It could mean retreating, taking critical infrastructure out of that area and putting it somewhere else, out of harm's way, and restoring that area to appropriate habitats. And I'm going to give you 3 examples of managed retreat, what that means. The first is an inadvertent example. We just got lucky. The second is how we're using our information to inform municipal decisions. And the third is work that we're developing into the future at a local scale. And then I'm going to take that local site work back to how we're expanding into the state level. So I have a special place in my heart for the California State University system. I worked as a postdoctoral researcher at Cal State Moss Landing Marine Laboratories for a year. And as you can see, the marine labs pictured up here in the top of this picture benefit from natural infrastructure. That beach is between them and the ocean. The beach, the tall dunes, the wetlands, the slough, more wetlands, and coastal chaparral provide protective services between them and the ocean for sea level rise and storm damage. But they haven't always benefited from these natural infrastructure. And I don't know if anybody else in the audience experienced the Loma Prieta earthquake of 1989. But I did. And I'm happy to say that I survived. And maybe I'm happy to say that Moss Landing Marine Labs did not. Moss Landing Marine Labs used to be located under this red X, right on the beach. But the earthquake ruined them. Now, we weren't necessarily considering sea level rise and natural infrastructure in our development planning in 1989. However, the rebuild of the marine labs is under incredible environmental scrutiny, under Endangered Species Act and California Environmental Quality Act guidance. And all this scrutiny moved the marine labs from that X on the coast to up here on this hill where they'd have the least impact to these sensitive habitats. So let's just see how these two different locations would fare given sea level rise in 2100. And again, this is simply due to tidal inundation. The original location would be underwater, but the current location is high and dry, safe up on a hill, and receiving the benefits of that natural infrastructure between it and the ocean. Again, this was not a planned or managed retreat, but this is an example of what we can start doing with our planning and our development to benefit both the wetlands and human infrastructure. Okay, so I've just given you a couple local examples, and the blue data there, the blue sea level rise data there, was data from our Coastal Resilience Monterey site. And we're expanding our Coastal Resilience network. We started in Ventura, expanded to Santa Barbara, and Santa Cruz and Monterey. We're partnering in Humboldt. And we're creating this Coastal Resilience network where we get the municipal decision makers together, where they can share their stories of adapting to sea level rise. They can share their successes. They can share their challenges. And they can look for similarities among these municipalities and differences throughout the state. And anybody's invited. We're hoping to learn as a society, as a state, to provide the leading edge of sea level rise adaptation to move into the future to a more resilient coast of California. So I just gave you an example from the Monterey Coastal Resilience site. And now let's take a look at the Ventura Coastal Resilience site. This is where we first landed on the California coast. We came from the East Coast. And this is where we learned two lessons. One, you had to really engage with the local decision makers and see what they needed. And there's a lot of back and forth between us and decision makers to make sure that we got it right. And we had to invest heavily in the science to make sure that we developed, as Patrick explained, a dynamic model. And this is a screenshot, again, an old version of that dynamic model. But as you can see, it's interactive. And there's a lot of bells and whistles. There's every bell and whistle you could possibly want. And we're increasing them through time. And you can choose your hazard scenario, whether it's tidal inundation, wave inundation, erosion, flood damage, river flood damage, and you name it. Shown here is tidal inundation in pink. And the darker the color, the deeper water, the water. And this is current time. And here's what it looks like in 2100. And we didn't have any goals for this. We didn't have any direction with this. We wanted to provide the best available science to inform the best decisions by municipal decision makers. And one key relationship that came out of this was the Department of Defense. The Navy base in Magoo. Magoo Lagoon, sorry. They manage a great chunk of coastal habitat, including over 2,000 acres of jurisdictional wetlands. And when we showed them these data, they became alarmed. And I think as I go through the next few slides, you'll see why. So here's the base in 2015. Here it is in just 15 years. And again, this is tidal inundation. And again, this is a dynamic model, as Patrick explained. And the darker the colors, the deeper the water. Here it is in 2060. Here it is in 2100. And when the Navy base saw this, they realized they had a problem on their hands. And they realized that the Nature Conservancy could be an honest broker to help them figure out different decisions and appropriate decisions to adapt to this. And we've already started partnering with the Department of Defense to do just that, to come up with alternative scenarios and then analyze the costs and benefits of each, both to humans and nature. So, for example, we could take the armoring approach. And that would entail protecting the key infrastructure that they need to maintain their base is this airstrip in the middle. You have to build a white seawall around that to protect it. But in order to receive the benefits of that white seawall, you would also have to raise a yellow levee along the river to protect against increased intensity, more frequent flooding. You'd also have to create new seawalls on the outer coast, and you'd also have to raise existing seawalls in order to receive these benefits. And again, these benefits might be short-term. and they might be costly. And again, by doing so, this increases the erosive forces, and these 2,000 acres of wetlands erode more rapidly and more rapidly and more rapidly, and they transition from these important wetlands providing important services to humans and nature to a deep bay. Or we could incorporate natural infrastructure into the planning. We could still defend in place that critical infrastructure in yellow, the airstrip, maybe even put a seawall around it. But then we could manage retreat, take other infrastructure and put it into that area. And then importantly, we could allow those coastal habitats to do their thing, to do what they've been doing for millennia in adapting to sea level rise and sea level rise changes, as Gary pointed out. And thereby also, the blue area is tidal inundation again. It's not necessarily loss of water, but it's allowing these habitats to do what they want and provide the services to both people and to nature, as I explained previously. So I've just given you two examples from our local planning, the local planning scale. But we're also taking this to a state level. And we realize there's a lot of partners that also act at the state level. For example, the Pacific Coast Highway stretches 600 miles along the California coast. We're now partnering with Caltrans to work on win-win solutions where perhaps natural infrastructure can provide benefits to their transportation infrastructure. And also perhaps rebuilding that transportation infrastructure in key places to allow natural habitats to migrate inland in response to sea level rise. The Department of Defense has many positions on the coast, highlighted here in red dots. And as you can see, state parks manage a majority of our California coast. And we're also partnering with the California Coastal Conservancy. We're conducting a statewide analysis in this thin band that I showed you previously of where our coastal habitats are, what the land use is, and how all this interacts with sea level rise through time to start to inform creative decisions of better managing our coastal habitats and our human infrastructure. Again, the mission of the Nature Conservancy is to conserve the lands and waters on which all life depends. And the examples that I've shown here demonstrate that conserving natural habitats is not necessarily at odds with conserving human infrastructure. And we're going to need to come up with new and creative strategies to do both of those things. We're going to have to protect where these coastal habitats are now. We're going to have to protect where they will be in the future and allow them to move into that area into the future. And we're going to have to incorporate natural infrastructure into our planning and our development so that we can work towards a more resilient California coast today and into the future in the face of climate change and sea level rise. Thank you.